Welcome to 4G Notes, Systems of Linear Inequalities. So we've done systems of equations, and now we're doing inequalities. Sorry, you don't need this part right here. Okay, so our objective is I will be able to solve a system of linear equalities by graphing through the in-class notes and activities. So what is a system of linear inequalities? This is two or more linear inequalities, and you're going to use them together to solve. And to remind you what an inequality is, that's when you have an equation with one of these signs in it. So greater than, less than, greater than or equal to, and less than or equal to. And we'll look at how to graph those in just a moment. Solution of a system of inequalities is a set of points that make all the equations in the system true. And the only way to find this, the only way to show these points is you have to make a graph. So shown by graphing. All right, make sure you get that down and then come join me for this part. First, we're going to look into graphing inequalities. So first, you're just going to graph the line as if there were an equal sign here. So we're just going to pretend like this is an equal sign, and that would be y equals mx plus b then, this being the slope, and this being the y-intercept. So I'm going to go to the y-intercept at 1. And now my slope is negative 2/3. So it doesn't matter if you use the negative on the top or the bottom, but make sure you only use it once. So if we have negative 2, that's going to be down. And then 3 is going to send us right. So 2 down, and then 1, 2, 3 to the right. Okay, so now we're going to graph the line, shade according to the inequality sign. I actually left something out here that I'll make sure that I put on your notes. But we first need to draw the line. This type of line would be for greater than or less than, because it's not going to include all the points that are on the line because it's not equal to. Whereas this kind of line is going to be greater than or equal to and less than or equal to, because now all the points on the line are also included in the solution. So let's go ahead and graph this. Because it's greater than and equal to, that means it's going to be a solid line. A solid line. Now I'm going to jump back here, shade according to the inequality sign. So it says greater than, with the greater than, the alligator mouth opening to the y. So that means we want all the y's that are bigger, so where the y's get bigger. So looking at our number line here, the y-axis, the y's are smaller down here because they get negative, and the y's are bigger up here because they get positive. So we're going to shade everything above the line. So there we go. Any point in here would make this inequality true. It doesn't matter which point I pick. I could even pick a point on the line because it's greater than or equals to. So for instance, if I pick the point 0, 1 and put in 1 here and 0 here for the x, then I have on the left side 1, and on the right side, well, negative 2/3 times 0 is 0, so that would just get rid of all of that, plus 1 would be 1. Is 1 greater than or equal to 1? It is, because it's equal to. So this point is a solution to this equation. We could also choose any point in this shaded area. It would also have to be a solution to the equation. So for instance, and I always like to use a point with 0 in it because it makes it easier to do the math. So 0, 2, for instance. So I'm going to put in 2 for the y and 0 for the x. That would give me 2 is greater than or equal to, this cancels out 1. Is 2 greater than 1? That is true. So let me show you how it wouldn't work. If I picked a point down here, for instance, on this side that's not shaded, like 0, okay, if I plugged in the point 0, 0 for my x and y, 0, 0, on the left I would have 0, and on the right, well, this all cancels out here because negative 2/3 times 0 is still 0, and then plus 1, well, 0 is not greater than 1, and that's why all the solutions over here would not work for this equation. All right, so let's go ahead and try another one. Y is less than 3. Well, this is the same. We're going to graph it like y equals 3. So if you recall, hoy vux, this would be a hoy, so a horizontal line at 3. So we're going to go horizontal, and then do I need to go dashed or solid? Well, it is not equal to, so we're going to go, or is that equal to? I can barely see it. It is equal to. I had to pull up the document to make sure. All right, so it is equal to, so that means we're going to use solid because the points on the line will also count. All right, so we draw in our solid line here. And then we have to think about where we're going to shade. So where the y's are less than 3. Where are the y's less than 3? Well, here's 3. Up here, the y's get bigger than, so we're going to go all of them that are less than. And we'll just shade this whole part down here. And I'm not going to test a bunch of points this time like I did the last one. But just know that any point that I pick within this shaded region, if I were to plug it in, would work, would make the equation true. Any point that I picked up here would not make the equation true. All right, last one we're going to do together here. So the x that's greater than -1, well, first we need to graph this line. X is vux, so vertical line at -1. And then now we are going to do a dashed line because it's not equals to. Okay, so here we go. And now we're going to shade where the x's are greater than. So where the x is greater than? Well, they're all to the right because it goes 0, 1, 2, 3, 4, 5. They're getting bigger, so they're greater than to the right here. So I'm going to shade everything to the right. Now, if I were to check a point on this line would not make the equation true. So let's pick a point on the line, for instance. Right here, this point is -1, 1. So we're going to try -1, 1. Notice there's no place to put in a y, so we're just going to put in the x. -1 for x is greater than -1. Well, that's not true. Right? That is not true. And that's why we have to use a dashed line to make sure we don't include those points. Okay, so now we're getting into actually solving by our systems, by graphing. So first, graph the first inequality and shade very lightly. So I'm going to go ahead and graph this one. So I'm going to go to -4, and then I'm going to count my slope, which is 2. So I'm going to go up 2 over 1. Then do I need a dashed or solid line? Well, for this one, since it's not equals to, it's just less than, I'm going to use a dashed line. And then it says shade very lightly. Okay, so we'll see why in a moment. So where the y's are less than this line. So where are the y's less than? Well, there's only a little piece there on the axes, but see how the numbers get smaller going this way and bigger getting this way? We're going to go where the numbers are getting less, so down here, and we're going to shade lightly. Just like that. Then graph the second line, again, shade very lightly. So let's go ahead and graph our second line here. My y-intercept is at +1. And now I'm going to go -2 and over 3. 2 over 3 goes off. So I want some points this way, 2, 3. And now this one does get a solid line. And now I'm going to shade lightly again. And it's the y's that are greater than this line. So where are the y's getting bigger? Above the line. So I'm going to shade in all above here lightly. And it goes all the way to the line here. Okay, now where does the shading overlap? That's the solution, shade that in dark. So we're looking for the part where the shading overlaps. And you can see already, since I doubled it up, it does look a little bit darker, but just so that we're clear, the solutions are all of these. All of this in here would be our solutions. So that means that if I chose a point over here, that would only satisfy one equation. If I chose a point here, that would satisfy one equation. If I chose a point over here, that wouldn't satisfy either of the equations. Only all the points in here would make both of the equations true. So test a point in the solution. So we're just going to test a point. And like I said, I usually like to do one on the axes because then I have a 0 to work with. So that would be 4, 0. And now we're going to see if it makes both of these true. Go ahead and try it for yourself. Plug in the 0 for y and the 4 for x, and do it for both of the equations here, and see if it makes them both true. Okay, so hopefully you paused the video and did that. But here you go. Here's all the work. Is 0 less than 4? Yeah, 0 is less than 4. How about is 0 greater than negative 5/3? Well, 0 is greater than any negative number, so that is true as well. So this, we tested a point, and now we know that we did it correctly. And it's always nice to do that to make sure you've done the problem right. I'm going to do just one of these, and I'm going to have you do the next two. But y is less than 3. So here's 3. It's hoy. So it's, sorry, right here. Hoy is going to be horizontal at 3, and it's going to be dashed. And then we're going to shade less than 3, so all of this down here. And now let's graph the other line. Y is greater than negative 2. Here's negative 2, dashed again. It's not equals to. And we're going to do all those that are greater than, so above here. And you can kind of see where they overlap. It's a little bit darker. Let's make sure that that's really clear here. But this is the solution. This is the solution. I'm going to test a point to make sure I did it correctly. This is always a nice point to test, 0, 0. So I'm testing the point 0, 0. For my top one here, when I plug in 0, is that less than 3? Yes. For my bottom one, when I plug in 0, is 0 greater than negative 2? Yep, that's true. So those are correct. All right, go ahead and try these other ones on your own. And then we'll go over them in the class and watch the rest of this. And once you've done them, rejoin me for the video and let's look at these problems below because they're a little bit different. Okay, consider the following. Write a systems of linear equations for the shaded region below. So let's start with this line. What is the slope of the line? Well, we'll find some points that are on the line. So like this point, or I'm sorry, that are at an intersection of the graph. So that one's a good one. As I follow this, it hits the coordinate plane lines again, right there. So my slope is up 1, so positive 1, and then right, so positive again, 1, 2, 3, 4. What is the y-intercept? Well, it hits the y-axis at 1. So what's my equation? If I put this in y equals mx plus b form, I get y equals 1/4 x plus 1. What kind of line? I have a solid line here. So I know that it's going to have equals to. It's going to be greater than and equal to or less than. So where is it shaded? Below. So finally, what's the inequality? So I'm just going to take this part up here, and in here I need to use this information to figure out what sign goes here. So since it's solid, I know I'm going to have an equals to part, so I'll go ahead and draw that in. And since it's shaded below, well, the y's get smaller down here, so the y is less than. Or the y is less than, just like that. All right, so I have one equation. Now let's try to find the other one. Once again, what's the slope? Now we're working with this line. Well, here I'm at an intersection point on the graph. And I am here too, so this will be a good place to count off my slope. So I need my up, down first. So I'm going down 2 right there. So that's going to be negative 2. And then I'm going right to positive 2. And negative 2 over positive 2 is actually just negative 1. What's the y-intercept? Well, it intersects the y-axis at 2. What's my equation? Y equals negative 1x plus 2. What kind of line? Well, it's a dashed line. Where is it shaded? So where is this shaded? Is it shaded down below or is it shaded above? Well, this part right here is above this line. So we're talking about greater than, so above. And then lastly, I'll put this all together, and I'm just going to drop the 1 and make this negative x. So greater than, and since it's dashed, I'm not going to have the little line underneath, so it's just going to be like this, greater than. So my systems of inequalities is y is greater than negative x plus 2. All right, so I've left a couple problems for you to do here, just like the steps above. If you don't know how to get started, please rewind and watch this again. You should at least try this. Okay, I understand if you struggle with it or it's hard, but at least try it. This one's just like this. This one's a little more challenging because we're going to have 4 different equations here, but just try your best at it. And I didn't write in questions here on my notes here, but any questions you have, go ahead and put them here and I'll answer them in class. All right, thanks for watching.